Let's meet Sane. He's based in Italy. He's a software craftsman at SourceSense, and he's really passionate about open source, and he focuses on scalable solutions in the area of enterprise search, grid computing, and high availability. He's a regular contributor to Hibernate, and you can find him on numerous open source projects. And when he's not working, he enjoys traveling and hiking. So with that, Sane, I'm going to go ahead and turn it over to you.
Hello, everybody. So I'm going to introduce Scarlet. Oh, there it is. And this is the project we have been working on in latest time. And so the first thing, what is Scarlet really? It is a custom edition of Atlassian JIRA. So we love using JIRA, and we are partners of Atlassian. We sell it to many big customers, and we often got the question that they would like to scale it also horizontally, because some of them have very huge installations. So it also solves the limitation of this standalone JIRA, which is not able to cluster in more than one node. And during the clustering, we are able to add more nodes dynamically or kill nodes. So this really eases a lot in management. So it is not a JIRA plugin, because many people around have been telling that it's just a plugin, but that's wrong. It is an edition of JIRA, so you have to replace your normal JIRA with our repackaged version. And we made it in a way that it's easy to deploy on a cloud, but it doesn't need a cloud. So if you have just internal nodes and want to control your own issue tracker, you just deploy it on your own machines. And it also doesn't need a cluster. You can just scale it down to one node, and you can also scale it to 0 nodes without losing data, and then scale up again when you have a higher load. And it doesn't cost more than JIRA, because we just sell the usual JIRA, and with our consultancy, you can get Scarlet from us. So we made it, as I said, because a lot of customers really want the failover capability. It is a pain when you have a very big enterprise which is relying on it, and it goes down because of maintenance or too high load or some issue anyway. Also, having just one node is quite harder for the maintenance from the administrator's point of view. If they have to replace something on this machine or just update the virtual machine, then they have to take the service down. And if you have more than one node, you can just send all traffic to the secondary node. And also for scaling, if you have a lot of issues, of course, JIRA standalone scales pretty well, and there are very huge installations. But sometimes it just gets too expensive to buy all the hardware needed for vertical scaling, and horizontal scaling is a nice option. And of course, because we are cool partners, we want to show off that we know the product that we are doing support about. So these are some of our customers, like in British Telecom in the United Kingdom. They have 25,000 users and manage more than 50 million issues with very complex workflows. In Italy, we have another huge installation with even more complex workflows, but a bit less issues inside. And we managed to push the performance in these cases, but it's just one installation. And because we care about the customers, we really wanted to solve this in a more innovative way. So from the technical point of view, what is Scarlet? It is a source code patch. So we maintain a set of changes to the source code of JIRA. Of course, Atlassian gives the source code to partners and also customers, so they can look into it, and they are free to change it. And we change mainly 3 areas. One thing we do is we enable caching through Infinispan. So JIRA has many caches inside, and we replace these to be able to have consistency across caches in different nodes. Another area we worked about is tuning at Lucene level. Lucene is the full text library, and it's a core component in JIRA. All statistics and queries that you do in JIRA with this very nice query language, which was introduced in latest JIRA, is based on Lucene engine. But Lucene is also a different topic to cluster. And so other points, we just remove some barriers in the internal services which enable us to go in clustering mode. Besides being a patch, we have quite a complex build system because we need to be able to repackage the stock JIRA quickly to react to security issues of Atlassian or new releases. We want to be able to release a new version of Scarlet as quick as possible. Also, what we release is not just a JIRA version, but we test it on virtual machines. So we have appliances of several types, and we can provide ready-to-run appliances for different virtualization technologies. And finally, I have a bit of a background as system administrator, and I really hate it when you have to configure to set up a failover system that you have to change or maintain many different configuration files. So this was really designed to ease the deploy and maintenance and use all technologies to do node auto-discovering and automatic reconfiguration. So InfiniSpan is quite a new technology, and it's a core component in Scarlet. So from the website of InfiniSpan, we get that it's an extremely scalable, highly available data grid platform. And what is especially so cool to build Scarlet around it is that caches built in InfiniSpan, they are configurable in several different ways to have different semantics, but the main point is that they implement a concurrent map, which is the same interface used by all different caches in JIRA, almost all of them. So what we do in Scarlet is we detect the usage of internal concurrent maps and other state management, and we replace them with InfiniSpan enabled same semantics. So the behavior of JIRA is exactly the same, just you can have it spread across more than one node. Also, another benefit of using InfiniSpan is that each cache gets advanced monitoring and statistics, so you can fine-tune every different usage to get the most of your hardware. And of course, it's not just a data grid platform, it is actually the new version of JBoss cache. So it has many internal enhancements to be used as a cache, and it has really state-of-the-art algorithms for maximum efficiency, like layers, which are just more efficient than the internal caches of which JIRA uses normally. And finally, InfiniSpan provides the access for the new slide. For Lucene, we can cluster Lucene storing the index. Instead of storing it on the file system, which is local to the single node, we can store Lucene's index in the grid directly, so that we get one consistent view across all nodes and improving performance, because we're not using disks anymore. We are using the shared memory of all nodes together. More that we do with Lucene is some other new features of the newest Lucene version, like shared buffers in the index reopening. And we pull the index searches, and this is also provided by InfiniSpan. We can do in-memory transactional writes. So when you need to guarantee something is committed, traditionally you should issue a flash to the disk. This is a slow operation. But through Infinispan, we can have a transaction committed in memory because the state change will be replicated to other nodes. So even if the current node is failing, the data is not lost, because before the commit operation returns, the other nodes will have received the copy and acknowledged it. So we can scale horizontally using Infinispan and Lucene on top of it. So this is a schema about how normal JIRA is structured and how that is changed in Scarlet. On the left side, you see the normal JIRA, which stores these indexes on your local hard disk and uses some internal caches, and then this cache, of course, speeds up the access to your database. In the case of Scarlet, the internal design and the semantics of all services of JIRA is exactly the same. Just the index is stored on Infinispan instead of the disk, and the caches are of the Infinispan implementation, and in the end you still write everything to the database. But you can see that the need for a local disk is not so important anymore. So having all state stored inside of Infinispan, you can have more than one node connected to each other and use Infinispan as the shared state of the application. And the best news about this is that I can just kill one of these machines and the system will stay up and running and no data is lost. I can add a new node and it will auto-discover the other nodes, get a copy of the state, and join the cluster. So you can, in case of high loads, you can just add more hardware or kill some nodes to scale down again when you have too much hardware dedicated to a JIRA installation. So which were the problems when clustering JIRA normally? Well, the first point is it has many internal caches which it uses to store state. So when JIRA changes one of these values inside these internal caches, it has to notify its peers about the same change. So for the caches, you can use replication, distribution, or invalidation through Infinispan. And depending on the use case, on the load, we choose one of them, or we can fine-tune the choice depending on the specific deployment needs. In the case of configuration settings, if you create a new project or change some of the main properties which configure JIRA, this state is replicated everywhere. Replication is more suited for this kind of work because it doesn't contain much data, but it's read very often by all nodes, so it's handy for all nodes to have a local copy of them. And finally, the Lucene indexes. Every kind of Lucene index you create inside JIRA is distributed or replicated across the network. Also in these cases, you can choose between distribution or replication depending on the amount of memory that you have available on every node and the space required to store the index. Finally, the last point you have to care about when clustering JIRA is these file uploads. You can attach files to the issues, and these are stored in the JIRA home. So JIRA home is not used only to store the plugins and indexes, but also these files, and these files need to be replicated to the other nodes. But this really isn't a big issue because network file system exists since many years, so you can use any of them. And to make setup simpler in future, we're thinking about plugging in Infinispan's GridFS. So that is not implemented yet, and there is a nice article on InfoQ about it, but the goal of that is to really simplify even more the setup of a Scarlet cluster. Also, session replication is not implemented at this point. So in case you're connected to JIRA and the node you're connected on fails, well, your browser will be sent to a new node, but you most likely will need to relog in again. That's really the minor point, the minor issue in all of this, because the service is still available and your data is not lost. Finally, you will need a load balancer to use it. And this technology is really independent from the load balancer, so any load balancer you might work for this. But if you use Apache HTTPD, we really recommend to use mod cluster, which is what we have tested most. Mod cluster has this advantage to be totally dynamic, so new nodes joining to the cluster in Infinispan will reconfigure the load balancer and say that they are available to receive nodes, and they also do server-side load balancing factor calculation. So what does it mean? That if one of your nodes is having a very high load because it's creating a report for one of the managers, and this report is taking many resources, then this node will notify the load balancer so that other people will receive responses from other nodes and not from the busy one. And at jboss.org you can find more information about mod cluster. It's another open source project. So this is the schema of the architecture of a Scarlet deployment using mod cluster. You can assume to have at least two load balancers so that they can do failover between them. And then you use the mod proxy model of Apache HTTPD, and you can have as many Scarlet nodes as you want in the backend, at least one to have the service running, of course. And you can add new nodes dynamically and remove nodes dynamically. They will notify the mod cluster model to reconfigure the mod proxy. In the backend, you just have your usual database, and Infinispan cares for communication across the nodes. When deployed on a cloud, there are some more issues to consider. The main one is using EC2, Amazon's EC2. The JGroups is not able to use multicast because multicast is disabled in the network. So some other technologies need to be used, and JGroups provides 3 alternatives to work fine in this kind of cloud system. One is to provide a list of the initial nodes. So it will ask these initial nodes what is the state, what is the topology of the cluster, and so it will get the updated list of nodes participating in cluster. Or, assuming you are using Amazon EC2, you can use S3. So JGroups will use S3 as a point to find each other's nodes, or set up a gossip router. A gossip router is a single node which cares about coordinating the other services and make sure that they will find each other. So we test Scarlet on EC2 using the RDS, which is the Relational Data Store service of Amazon. It is basically a MySQL service. And I just give him our EC2 credentials, and our build system will then produce a pre-configured Amazon machine, and I can start n of them. So if I want a cluster of 5 nodes or 10 nodes, I just start 10 of these gold master instances, and I get a 10-node cluster, and then I can begin killing some of them or adding more in the future, depending on the load. This has some nice effects, because every node is stateless, so there is no important data on top of them. So I don't need to backup any state of the machine. I can just kill them and throw them away. And of course, as I need more, I can just start one from an older version I have, because there is nothing to update on this machine. And to do a backup, I just have all of what I need in the database, or in S3, depending on what I use. And so I have just one resource to manage and to backup eventually. But the build system is also able to produce ready-to-run appliances for other virtualization environments. It's using JBoss Box Grinder, which takes a template and is able to build and customize the appliance image for different targets like VMware, Xen, or KVM. So every node is equal, and there are no master nodes, there are no passive nodes, and this means that it makes best usage of all the hardware you have around. There is not a single machine which is just idling around doing nothing useful for the cluster. And to install it, it's really similar to a standalone JIRA. Just uncompress it. You configure a data source. You will have to set where the file attachments have to go. Remember, JIRA Home is just containing that as now. And optionally, you can do some tuning, of course. There are many options of different kind of tuning you can do around the indexes, the caches, the network settings, but out of the box it should just work fine. And if you start many nodes in the same network, they will just form a cluster automatically. You don't need to set up anything special, besides checking that the firewall will let them communicate each other and the network is also set up. So to upgrade to Scarlet from a JIRA instance, you just have to replace the package, keep your configuration files. I assume that you already configured the data source, and you can start it. It will detect the indexes from the position they were configured previously and load them into the Infinispan directory. It will also use an additional table in the database. This additional table is used to give a permanent store of the index itself. So when you shut down all nodes and start it again, your indexes are not lost because they were stored in memory, but you always have a copy inside the database. So when you make a backup of the database, you store all data, besides the attachments, of course, but you have a consistent view of your database and your index. So to revert, if you have some issue with Scarlet and you want to go back to JIRA, you just have to replace your package. And you can optionally delete the extra table. You don't need it anymore, but you can also leave it where it is. And you should perform re-indexing, because I assume that you might have changed something in the index, so you might want to re-index again. Finally, we have to check for full plugin compatibility. Until now we checked Fisheye and Greenhopper. They both appear to work just fine, but there are many plugins out there, and we have to test each one, and I don't know what could happen there. I expect them to work, because when we checked Greenhopper and Fisheye, we didn't have to change anything, because these two plugins were written, I would say, properly, so they are not keeping internal states of special sort. They are relying on the JIRA APIs and on the services provided by JIRA, which are already patched and clustered. So to the plugin developers, if they have problems with compatibility with Scarlet, you should check to use the JIRA services as they are, especially to use JIRA's cache factories and not your own ones, because they couldn't patch your own code. And of course, we are available for help, because I'm very interested to have all plugins out there working on Scarlet as they work on JIRA. And how to get it? Well, we don't charge for the package itself, so if you want to beta test it, you can get in touch with us. And as we are Atlassian's partners, we are used to do big installations and deployments. Well, Scarlet is just a part of our services. So when we come there to fix performance issues, if you see that you need Scarlet, you just get Scarlet from us. And please mail us at atlassian@sourcesense.com if you need some more information. So in the end, this is just JIRA is already integrated with Lucene. As I said before, it's a core component of Lucene. And SourceSense is very strongly influenced by open source community. We contribute to a lot of open source projects. And so some of us are contributing to the Apache Foundation and some others to the JBoss community. And in this case, what we did is really integrate very cool technology which is around and is open source. The most complex parts of the components of Scarlet were actually pushed back into the other communities. So the Lucene clustering technology, you can find that in the Infinispan community. It's open source. And some bug fixes were sent to the Lucene community. And also to Atlassian. They are not totally open source, but we could say they are because they give you the source. We also sent some mails with Atlassian's developers, and we help each other about the development of Scarlet. Thank you.
All right, thank you. As we said earlier, if you guys have any questions, please feel free to chat them in. I do see a few questions already showed up, so let me take the screen back over and we'll start asking those questions. One question I had, what's the largest installation that you've tested or deployed?
Oh, largest. Well, at this moment, there is the JBoss community itself, which is testing it. So they didn't deploy it in production yet, but that's a very large deployment because it's public-facing. So everyone which is using a JBoss community project can look into their JIRA installation. And there are many, many projects. And so they are very interested in trying it out, and they are testing it right now. Okay. And for ourselves, we just have toy deployments inside Amazon, but they are not really used.
With the JBoss installment, do you have any idea as far as JIRA stats on issues or users or anything like that?
Not yet, but as I said, the number of users is really the internet or all developers around the JBoss community, which is pretty much.
Okay. And you did show a slide towards the end regarding compatibility with plugins, but someone chatted in, what are the constraints to take into account for plugin development to be usable with Scarlet?
Well, it's just about the caches. If you are caching something which is not going to be changed by your own plugin, so you are like caching the result of a complex formula, then that's fine. But if you are caching some of your own computations, then you should consider that another instance of your plugin is running somewhere else, and they could have different state. But JIRA is containing a cache factory, so if you use that, you will get the clustered cache back. You won't see it because it's implementing the same interface, so it will just work.
Okay. And along the same lines, what are the constraints with Scarlet for plugin version 2 installation with or without the universal plugin manager?
I think just the same.
Yeah.
So you have a clustered file system where the plugins are deployed, and this event will change state inside JIRA, and this state is clustered, so it will affect all nodes at the same time.
Yeah. And this question I do believe you covered towards the middle of the presentation. but just for clarity, if you're migrating from JIRA to Scarlet, is there a required import, or can it be using an existing JIRA database?
Yes, we saw the slide about that in the middle also, and the database is exactly the same. I don't touch anything of the original schema because I don't want to do that. I think that people wouldn't trust my product if I did. But there is one additional table which is to store the index, but you can delete it at any time and rebuild the index. So there are no changes really.
Okay. Does putting the leucine index into the extra table in the database make JIRA very slow for querying?
No, that's a very nice question, because well, the storage in the database of the index is asynchronous, but it's managed by Infinispan. So usually when you do something asynchronously to your main transaction, you lose reliability. Because if your node fails and it didn't perform the change yet, your change will be lost, but it said in response that it was done. But in this case, the transaction is committed cluster-wide, and only after that the cluster will merge the changes and in background will update the database.
Okay. And here's a comment. The JIRA Subversion plugin creates an index in jira.home/caches/plugins. Can that be supported?
That is already supported. That was a nice surprise. I didn't do anything special for that, but when we tried it, I went to look, so what did it, and it just clustered at the same index.
Okay. And someone chatted in, JIRA has the arbitrary limitation of around 200,000 issues per instance. What causes this issue, and how does Scarlet get around this?
Well, this arbitrary limitation, it's not a limitation of the software. There are no limits inside. It's more that if you cross this line, you are getting scalability issues on a single node. So again, there is nothing special which is needed to do to cross this boundary. You just deploy more nodes, and it will scale better.
Okay. And this is something that wasn't covered in the presentation, and I was curious myself as well, but someone chatted in the question, which JIRA versions does Scarlet support?
Oh, well, the latest. It's 4.1.2 right now, and I am having patches ready for the beta, which is 4.2 beta milestone 9. So as soon as they release 4.2, I will be ready with Scarlet for 4.2.
Okay. And all right, thank you. Someone chatted in, we have customized JIRA core code. How can we deploy Scarlet and still keep our changes?
Oh well, I think we can merge our patches and build the merged version.
Okay. And are you able to combine multiple JIRA instances to a new Scarlet instance?
Multiple JIRA instances. Well, I assume they should be configured all the same, because I wouldn't know how to deal with conflict resolution. They really become one thing when you get them in Scarlet.
Right. Are there any plans for additional database support?
Well, it supports all databases which JIRA also supports. I'm not messing with the database with the persistence layer, really.
Right. Here's a question which is interesting. It's kind of directed to both of us. Will Atlassian provide support for this product at all? I assume not. And if a customer uses this product and has JIRA support needs, where can they go for support? And this is from another partner. They've gotten this question a lot in the past. So I know that if you tamper with your code, I think Atlassian support stance is they won't support it completely, but they would definitely try to help figure out what the issue is. Now, on your end, would you provide support for something like that?
Yes, of course we provide support for that, and as Atlassian partners. So if we need some help from Atlassian, I've seen that Atlassian's support for our partners is really good, and for all questions regarding Scarlet, we support them, of course.
Okay. What are the things they should watch out for when using Scarlet? Is there any known limitations?
No limitations. Well, the fact that session is not replicated yet, I think that's a limitation at the moment. And I might be a bit late. There might be a bit of a time gap compared to the releases in JIRA, but we really focused a lot on our build system to be able to respond very fast and to auto-test code, so it should be a matter of a couple of days.
Okay.
Technically, I don't know yet. We still have to see the limits of it.
All right. Have you tried setting up Scarlet together with WANdisco JIRA multi-site?
No, not together, no.
Okay. And has Scarlet been tested with geographically distributed sites, and is there any impact on performance for users of one given node?
Well, that's a tough question. Well, most of the clustering, most of the traffic which Scarlet is using is really asynchronous, but not all of it. So for those cases where I need a synchronous answer from the other nodes, it will impact performance, of course. And we didn't really test geographically distributed. That's more an issue of Infinispan. I'm a contributor to the Infinispan project, and they planned for the next release to test geographically wide area network distributed Infinispan cluster. So as soon as Infinispan supports it, then we can test it in Scarlet.
Okay. And someone's asking, what's the URL to find out more details about Scarlet? They can't find it on sourcesense.com.
Right. Well, we didn't disclose much information yet, but really, all you can ask us. You just post something to the forum on SourceForge. I will answer that. Or if you want to look inside the technology used for clustering, Infinispan is open source. The Lucene directory, which is clustering Lucene on top of Infinispan, is also open source. It's one of the models of Infinispan. And so all complex pieces of Scarlet are really open source and have their own communities. So, but drop me a line and we'll be happy to answer.
Okay. Sounds good. And yeah, with that, a lot of people chatted in regarding getting the slides. So if you guys email Atlassian@sourcesense.com, Sane would be able to give you the slides directly. And if you want to contact me, you can contact me directly at webinars@Atlassian.com. And this, this recording, as I said, or this webinar, as I said earlier, is being recorded. It'll be archived on Atlassian.com/TV. And just one last plug for an upcoming webinar. We have Ops Hub, which is JIRA integration to Alm tools. And you can follow all of the events that I have upcoming at Atlassian.com/about/events. And with that, Sani, I wanted to thank you for presenting today. I think a lot of people were very interested. And if you'd be able to get the slides out to them.
Sure. Thank you very much.
Do you have anything else to add?
No.
All right. Thank you for everyone for tuning in. Until next time. Bye.
Okay. Bye.